Personal finance presentation using Excel. Decision to buy appliance with a net present value calculation. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information is on the left-hand side. We're going to populate that into the blue area on the right-hand side. Scenario being, we're thinking about the purchase of a dishwasher. You can run similar scenarios for many different types of purchases. The general idea being a net present value type of concept, meaning we would like to measure the cash flow benefits versus the cash flow inflows and outflows that would be taking place over a longer period of time. If we have a long period of time that's impacted, then we want to be taking into consideration the time value of money. So normally with these kind of items or these kind of calculations, usually the outflow is up front, right? We have the outflow going up front, money going out, and then we have to think about what the benefit is going to be. That's often, of course, the difficult component because we have to think about the benefit in terms of dollars. Oftentimes the benefit being in something like this, possibly time saved. We want to then see if we can convert that to measure it in the ruler that we can compare, which is dollars, so that we can then measure it to the cost. And then we want to present value those cash flows. So the idea being we're gonna look at the cash inflows and outflows, present value them to the current point in time today using a discount rate so that we can then compare the two and see if it's worthwhile in order to make the decision to purchase or not. So we're going to say the cost is the $3,000, the savings per year in time, and we have to convert it to dollars. So I'm going to say $20 in time. We're going to save $20 in time times 52 weeks. I'm going to average and say that's going to be the 1,040 of time that will be saved each year. Assuming then that the dishwasher lasts for 5 years, then we're going to say that it's going to be saving us that amount for each year for that 5 years, and the rate of return is going to be the 4%. Now remember, the rate of return is another area that you have to think about how you're going to basically figure the rate of return. You want to at least be considering the inflation rate that would be taking place with regards to the measuring tool, the time value of money, which is usually between 1 and 5%. You can also think about the opportunity cost, which would have an impact in it as well. In other words, what else could we be doing with that $3,000? Could we invest it somewhere else and possibly be getting a return on it? In other words, if I invested it somewhere else, possibly I could be getting a 4% return. Therefore, we could see the opportunity cost as at that 4%. Okay, so this is the general calculation. We'll probably see this method used again, possibly for other purchases such as a car or something like that. So we'll say then the present value, it's going to be taken into consideration. By the way, present value calculations, we took a look at present value calculations in the past, just in terms of how to do present value calculations. If you want to brush up on those and pick up the skills on that tool, take a look at that, and then we'll be using those tools as they are appropriate going forward, which they often are whenever we're making decisions that will impact multiple periods. So we're going to take the present value of an annuity. This is going to be the annuity of the series of benefits that we're going to be getting, meaning we're going to have a benefit of 1,040 per year that we're going to imagine. We're going to take the present value of that by saying negative present value, shift 9. The rate is going to be the 4% down here. We'll say comma. The number of periods is going to be 5 in terms of the 5 years, comma, and then the payment we're going to pick up at that 1,040. So that's going to be the benefits we have that we brought back to the current time period because we assumed these benefits basically happening, 5 years into the future, bringing them back to the current time frame. And then we compare that to the cost of the dishwasher, which is of course the $3,000. And we come to a positive number, which is going to be the net present value, which is going to be equal to the 4,630 minus the 300. Underlining this, font group underline, and there we have it. So anything that's positive then would mean that we cleared the rate of return of the 4%. In other words, even if this was 0, this came out to be 0, we might then still want to pick it up given the fact that basically we cleared, in essence, the rate of return that we were looking for. So this rate of return, in other words, takes into consideration what we could be doing with the money elsewhere. So if I could put it somewhere else and get a 4% return, then if this came out to be 0, that means or 1, anything above 0, we cleared then that rate of return. So, and then you could of course change this. I could say, well, what if this was, what if I can get a rate of return of 7 or something like that and start to play with the rate of return. You can also think about what rate of return would you need in order for that to be 0. And we'll do that calculation shortly as well. Now, notice here we assumed a nice even outflows of 1,040 each year. You can imagine situations where you're buying something up front where possibly the outflows aren't as even, or even if they are as even like this, it can be useful to break it out on a year-by-year basis. And that also just helps us out to understand what this annuity calculation is actually doing. So let's do that. Where instead of doing the annuity calculation for 5 years, we'll take out the present value of 1 for each of the cash flows. So what we'll do is we'll start off with period 0, and then 1, and then 2, and so on. We're gonna select those 3 cells and autofill that down to 5 periods. Then I'm gonna go to the alignment and center that. And I'm going to start off in period 0 with the outflow, assuming that we're going to be paying for it at this point in time. No present value really necessary because we're at time period 0 here. So this is going to be negative. I'm going to represent the outflow as a negative number of the 3,000 at period 0. The present value, you don't need a formula for it, but I'm going to put the formula in there anyways. It's going to come out to the same number because we're at period 0, because it's nice to have the outer column uniform and then simply copy it down. And so we'll see that. I'm going to say negative present value, shift 9. The rate is going to be this 4%. Now, if I was going to copy this down, I would need to make that absolute. So I'm going to say F4 on the keyboard, $ before the B and 6. You only need a mixed reference, but an absolute one works. Then comma, number of periods. It's going to be period 0, which I'm going to pick up by having this periods column. Note that having this periods column is quite useful because that allows us to copy it down so that the next period will be 1 and so on and so forth, instead of just hard coding or typing in 0, which means that you'd have to type in a new number each time. And then the payment, we don't have a payment because this time we're doing a present value of 1 calculation, comma, and then the future value is going to be that 3,000. So I'm going to say enter. I get to the same number because we're at period 0, but that allows me to copy this formula down. And then the next one is just going to be equal to the 1,040, which is going to be our benefit, which is kind of like the inflow. I'm going to say F4 on the keyboard, making it an absolute reference. I'm going to copy that one down now, putting my cursor on the fill handle, dragging it on down. So we've got the 1,040 on down. That's going to give us a total here. Let's sum it up, equals the SUM, shift 9, up arrow, holding down shift, up on up to the 3,000. So we have a benefit there of the 2,200, font group and underline. So that would be just in terms of dollars, not taking into consideration the time value of money. It's going to be slightly less when we take into consideration the time value money if I try to discount this future benefit back to the current time period. So we'll do the same calculation a couple more times and then we'll copy it down. So it would be the negative present value, shift 9, rate is going to be that 4%. If I were to copy it down, I'd want to absolute reference it by selecting F4 $ before the B and 6. You only need a mixed reference, but an absolute one works. Comma, number of periods is going to be 1, which I'm going to pick from here, meaning this is the inflow we're assuming we receive 1 period out. So we will pick that up, and then we're going to say, and I'm picking that up with a cell over here, so when I copy it down, it will move down along with us. And then we're going to say comma, and then 2 commas because this is not an annuity, but present value of 1, and then pick up this number. And then let's do it one more time. And so notice it's a little less, of course, up to 40. Negative present value, shift 9, rate is going to be the 4%. I'm going to select F4 on the keyboard, making an absolute $sign before the B and 6, comma, number of periods. I'm going to say is that cell, which is 2, which will then copy down when we go down, comma. It's not going to be a payment, so we're going to say comma again because it's an annuity calculation. Then we're going to be picking up this 1,040, and enter. So now it's down to the 962, grabbing it with the autofill handle, dragging it down. There we have it. And so now, of course, if I go down to the third one, that 1040 benefit 3 years out, discounted back to the current time would be the 925. And if we say 4 years out, discounted back at the 4%, we got the 889 and then the 885. And then let's sum this up. Summing up the outer column, we then get the 1,630, same 1,630 we got over here, and we can see the breakout on a year-by-year breakout. Now, you might then, the next question would be, well, what if, how high of a return would I need to get, like if I was to take the money, the 3,000, and put it into an investment or something like that? How high would the return have to be in order for this basically decision to be a break-even point? So how high would this rate have to be for this amount, in essence, to be zero? We can use an IRR, we call it formula, IRR. You can also of course just play with this number and just bring it up. Well, what if it was like 10 or something like that? And once this gets to zero, then you're at the rate at which that would be zero. We call that the internal rate of return when we do this in like a, corporate finance or managerial accounting. And there's a formula for the internal rate of return. To pick up the formula for this, you would need to set up your column just like we have it here, meaning that outflow needs to be negative, inflows positive. Once you have that, it's just like the sum function. We can just say equals the IRR, I call it the and then it's going to be of that cell, the 3,000 on down, and then we get our percent. We're going to say numbers group, percentifying it. So at 21%, 21.66. So in other words, if we built up this same series of payments, but instead of using 4%, we used 21.66%, then we should get to zero at the bottom line. Let's try it out just to practice again. Say 0, 1, 2. We're going to select those 3 cells and buckle our shoe and then we're going to drag that down. We're going to then alignment and center. And then this is going to be an outflow. I'm just going to copy the same flows here. Copying the same flows equals the 3,000. Copying that down, putting our cursor on fill handle, dragging it down to the bottom. There we have it. Underlining it, font group and underline. Present value this whole thing, but this time using the IRR rate, negative PV shift 9 or brackets. We're going to be picking up the rate. That's going to be that 21.66 this time instead of the 4%. I'm going to make that an absolute reference because we don't want it. We want to copy it down and we don't want it to be moving. So I'm going to select F4 on the keyboard, $ before the H and 10, comma, number of periods. I'm going to pick up the 1 or the 0 over on the left-hand side. Comma is not an annuity. That's not a comma, that's a period. Comma, it's not an annuity. It's going to be a present value of 1, so 2 commas, bringing us over to the future value, which will be that 3,000. We're going to get the same number due to us having a period of 0, but we'll be able to copy it down. So I'm going to say enter, put my cursor back on that cell, put our cursor on the fill handle, drag fill handle down, and there we have it. Let's put an underline at the bottom here by going to the font group and underline. This is going to be our total. And then let's sum it up. Equals the SUM, shift 9, up arrow holding down shift, and there we have it. We've got the 2002, copying that over, fill handle, dragging over the fill handle, and there we have the 0. So this is the percent at which our net present value calculation would be 0. So in other words, we'd have to basically be making if we made 21%, if we took that 3,000 was able to make 21% or 22% about, then it wouldn't be worth it. We'd end up with a negative number on this calculation. So both of those ways are useful to see it. So with this calculation, fairly straightforward kind of calculation. Again, the things you got to keep in mind, of course, to do this type of analysis whenever you're looking at something that's going to be impacting more than 1 year is try to equivalate what the cash flows are going to be. So obviously the cash outflow, usually straightforward if you're paying cash for it. the inflows or the benefits you got to take into consideration in the future are going to be more difficult to determine, and you have to measure them in terms of dollars so that you can then take that stream of payments and present value it. They may not always be even. You might not always be saying, I'm going to have an equal number of benefits over the future, but whatever the cash flow is in the future, you can then list it out and present value it and do this kind of analysis, which is often done in managerial or corporate finance type of calculation. And then, of course, the rate that you're using, you want to at least be picking up the interest rate, of course, but then you might also want to be thinking about opportunity cost, what else you could be doing with that $3,000 to see if the current decision you're making is over and above the opportunity cost that you could be doing elsewise with the money. And then it would be if your net present value calculation is anything above zero. So if it's above zero, you cleared your rate of return. So even if it's 1, that would be good because you would have cleared, in this case, the 4%.